Okay, hello everyone. Welcome to week two. Today we're going to be going a little bit more in depth with sketches and stuff like that. So last week we kind of did the basics with basic shapes and simple extrudes and revolves. Um, but we're going to take that a little bit uh, and expand on it and kind of take it to the next level. So you'll be using these sketch tools pretty often when you start to design things. So it's a pretty good idea to get pretty familiar with these tools, just because they're very useful. So last week we were talking a little bit about constraints, mainly the dimensional constraint, right? So we were taking, a point or a line or an arc and setting its diameter or like a relative distance between two different places. And that's great for a lot of things. But there's also a bunch of other constraints that we can utilize when designing stuff. And although you technically could use like dimensional constraints for everything, some of it is like unnecessary. And we're going to be teaching you some of the extra constraints um, this week. So yeah, the constraints, kind of define where your sketch is along, your whole design. But there's a bunch of different tools that you can use. So again, we used the dimensional constraint last week, but we're mainly going to be going over geometric constraints. So things like parallel and perpendicular are really useful. And instead of just setting two things to be 90 degrees from each other with like the dimensional constraint, you can just click two lines and have them set to be perpendicular. And generally, that just kind of makes your sketch a little bit cleaner. It's a lot easier to read instead of having numbers just everywhere. And, you know, it allows you to kind of focus on the certain things that you might want to be able to change later. So, for example, if you know this design might change in the future, but this thing you might have might be always perpendicular, you can just set that to be perpendicular and then have some dimensional constraints elsewhere to be in, in a place that you might want to be able to specify more. Um, that might sound like a little bit confusing, but you might start to understand it a little bit later. Um, so yeah, there's a bunch of them up here. The one thing that I would recommend you try to avoid is using the fixed constraint. There's very like rare cases where it is like useful, but for the most part, using the fixed constraint will kind of take an arbitrary measurement and lock it in. And to make a precise design, you kind of don't want to do that. You want to make sure everything is dimensioned properly. So please try not to use the fixed constraint. I'm going to teach you how to use it today, just so you know. But in general, when you're making sketches, I try to avoid the fixed constraint as much as possible. But the other ones are probably pretty self-explanatory. You may have heard a lot of these words like parallel, perpendicular. Midpoint is pretty useful when you want something to be, on the middle of a line or something like that. Concentric, when two circles are on the same center point. Collinear, when two lines are on the same line. And coincident is very useful when you can take either like a point or a line and then have them touching each other. Here's some more of them. Horizontal and vertical is also useful. Sometimes when you draw a line, Fusion will automatically make it horizontal or vertical. But if it doesn't for whatever reason and you want it to be that way, you can use that. Tangent is when you have a line just going, tangent to the circle. If you take in geometry, we used it last week for the game piece. So, making that line have a very nice transition into that arc. That's what tangent's really useful for. Smooth, I don't really use it that much, but if you do want to use it, it's there. But yeah, then there's equal and symmetric. That kind of, it's all self-explanatory. But yeah, basically, we're just going to have everyone run through this little geometric constraint exercise. I know I've been talking about having things fully defined, but all of these lines are just going to be floating in space. So don't worry if all your lines are blue. This is mostly just so you can understand how the different constraints work. So if you're in the Discord, which I hope you are, you can go under the resources tab and then find this geometric constraints file. And then you can just download it real quick. And then we'll be uploading it to Fusion. So launching Fusion real quick. Is anyone having trouble getting the file? I hope not. Okay, cool. Okay, so I'm just going to open this file. My Fusion's being a little bit weird. So I'm just going to open this file from my computer, and then I'm going to find it. Typically, I would just upload it into my Fusion drive, but Fusion's being a little bit laggy today. Okay, cool. All right, well, I'm going to just do that again. So to upload files, you can just find the place that you want to upload it and then go under here. But you can also do like the open file from computer thing that I just did. I just like uploading it just because it'll allow me to access it if I, open Fusion on another computer. But yeah, just gonna open this, and then we'll be greeted with this partially completed design, right? So in the timeline here, you can see that there's this image with kind of the instructions on it, along with a plane and a sketch. What we're going to do is we're going to edit the sketch so we can manipulate all the different features on here instead of creating a new one, right? So make sure down here in the timeline, you're editing an existing sketch, which is this one right here, instead of making a new one. So I'm going to right click it, click edit sketch. It'll kind of fly into the plane at which this sketch was made, and then we can get started. So right here, we're just going to start following these instructions. So it says to make perpendicular. So we want to make these two lines perpendicular. Up here, these red icons are geometric constraints. If you're missing some of them, you can usually click this drop down and then it'll give you the rest of them. So in this case, I want these lines to be perpendicular. So you can either click the constraint tool and then select the two lines, or you can select the lines and then click the constraint tool. It's just kind of up to you. Personally, I like selecting the lines first, but it's just a personal preference. So when I do that, I just hold shift. You can see these lines get highlighted a little bit more, and then you click the constraint you want. In this case, it's perpendicular. You see when I click that, lines are nice and perpendicular. It's what we like. Over here, I'm going to make all these three lines parallel to one another. You can see right now there's like a blue square around the perpendicular constraint, and it's because like I'm in the perpendicular tool, so I need to exit that so I can either click on another tool or press escape. to just exit those tools entirely. In this case, I'm just entering into the parallel tool, and then I'm going to start making these parallel. One thing you might notice is that sometimes the lines might act in a weird way, and it may not just act in the way that you might think is logical, but basically Fusion will try to solve like the problem that you give it in the easiest way possible. So especially for things like horizontal and vertical, I'll just do an example up here. Fusion will try to do something to make its life easiest, right? So let's say I have this line here, and I wanted it to be vertical, right? But if I use this horizontal vertical tool, if I click on it, it's going to make it horizontal, right? And it's just because like this line is closer to horizontal than vertical. So Fusion just kind of takes the path of least resistance to solve for the constraint that you give it. So sometimes in your sketches, you might have to massage your designs a little bit to kind of encourage the constraint tool to go in the way you want it to go. So in this case, if I wanted it to be vertical, I could drag this line to be a little bit closer. Yeah, you can drag this line to be a little bit more vertical, and then when you apply the same constraint to it, it should behave in the way that I expect it to, right? And you'll kind of get a better feel for this as you use the tools more. But sometimes you might have to move your design manually to kind of encourage the computer to do what you want to do. Oh yeah, so to undo the constraints, you can just like control Z it. Sometimes you have to do it a couple times. The other way you can do it is you can find the constraint in your sketch. So in this case, you can see this little icon right here, and that is the individual constraint that I've applied to this line. So you can delete it by just like clicking on the constraint and pressing delete, and now I can, manipulate this. If you can't see it for whatever reason, I believe there's this constraint check mark here. So it'll kind of allow you to like hide and show the constraints. Um, it's not always like super reliable because you can see here like I made these perpendicular and it's kind of hard to see, but if I like move my mouse in like the right spot, I might be able to find the constraint. Like I think it's this one right here. No, where is it? There it is. So you can find them. Sometimes they're just a little bit hidden and it's kind of annoying. So one of the things I like to do, I find it faster a lot of the times to just like delete something, like delete a line and redraw it and then reapply the constraints. Especially if you've gone like really deep, you've made like, 5 or 10 lines later, you don't want to like control Z all of it. So a lot of the times I just delete it and then make a new line or a circle. Um, obviously, it depends on use case, but yeah. With that, I'm just kind of gonna let everyone free to kind of do this assignment. If you have any questions on like each individual one, feel free to raise your hand and I can come by and help. I think there's a couple a little bit more like complex ones that I might do for everyone, but I'll just kind of let everyone go to see if they can figure these out on their own. So maybe about like 10, 15 minutes or so, and I'll just be walking around the room. But yeah. Okay, some people are having questions about the third one with the three circles, so I'll just go over it real quick. Let's see. Basically, oh geez. Um, it says to dimension circle number 3 to 2 inches. So that symbol next to the 2 is like the diameter symbol. So you want to take this and use the dimensional constraint from last week and set it to 2. And then it says to fix circles 1 and 2, right? So again, like I don't usually use the fixed constraint, but this is just kind of how you would use it. So you could fix the circles by clicking on them and using, clicking on that lock button right there. You'll see that they kind of turn like that yellowish green to kind of signify that it is fixed. So, if you do use a fixed constraint and I open your sketch and I see this, I'll be able to tell right away. So yeah. Anyways, the last step on this is to make circle 3 tangent to both circle 1 and 2. So you use the tangent tool, and then you can just click on 2 circles, and then click on another set of 2 circles, and then there you go. Does that make sense? Hopefully. Okay, cool. have any questions on this assignment? Is there one that I should go over before I move on to the last one? So for this last one, there's like technically a couple like correct answers. Um, a lot of the times I see people like putting all the points on top of each other and basically making all of them concentric, and that's technically true. So I'll give you full points for that if you want to do that. But I think the kind of intended way is to have all the circles separate and kind of on their own like invisible line. So the way I'm going to do it is I'm going to be using the horizontal and vertical constraints. So, these are all kind of free floating. So I'm going to kind of make them all on the same horizontal plane. So I'm going to use the horizontal vertical constraint. I click that there. And then I'm going to click the centers of the circles. So clicking these two made them both on the same horizontal plane. But you'll probably notice if I was to do it to this circle and this one here, it'll kind of break it and then it'll make this vertical, right? So like I was talking before, sometimes you kind of have to manipulate your sketch a little bit to kind of help Fusion decide which way to go. So in this case, because I want it to be horizontal, you can see I'm dragging it to be pretty close to it. I like making it pretty close just so I can confirm that it's going into the right place when I apply the constraint. If it's like super duper close, then like it may not, sometimes it may look like it does nothing. So you might notice when I make sketches, I might purposely like draw something in a direction that I don't want it to go, and then I'll fix it with a constraint later. So again, horizontal and vertical, gonna click this one, and then boom, there you go. Oh yeah, collinear works as well, but I also make sure that you're not using like the fixed constraint. Just keep that in mind, because for most things, just don't use the fixed constraint. We won't really, for any of the assignments that we'll be doing, like, please don't use the fixed constraint, because like you shouldn't need to use it to fully define your sketches. Obviously for this assignment, everything's blue just because it's floating around. But for like the assignment we're gonna do next, please make sure that you don't use that constraint. Yeah, the collinear function is really useful. But again, there's more than one way of doing it. That's just kind of how I did it. So if you want to do it another way, that's perfectly fine. But yeah, any other questions about this assignment? This one? Okay. Yeah, so this one is fix point C and then make endpoints A and B coincident with point C. So I think this A should probably be closer to be up here, but you just want to make this point and this point coincident along with B. So I'll do that again. I'm going to fix point C, which is here, and then I'll make these two coincident, and then it's just like that. Yeah. Then the letters don't kind of float with the lines, which is kind of annoying, but yeah. Any other questions? So coincident is basically like making something like it's almost like merging 2 points. So in this case, you can see like point B is here, and then I made like I set it to be coincident with point C. So when I click these 2 points, they'll kind of fly to each other. In some cases, in your sketches, you can make something coincident that doesn't touch. For example, you might have a line, um, like, we have some line here, and then like some other line here, and then we might have like this distance is always like 5. I believe this might be a bad use case, but you can still set things. Okay, yeah, it's getting upset. Maybe not this example, but in some cases, you can have something be coincident with something else, even though it's not touching. So in this case, I think horizontal vertical might be more applicable. But yeah, most of the time they will be touching though, so I wouldn't worry about it too much. Any other questions? Okay, sweet. So now that you kind of all know the general idea of how these constraints work, we can just start designing more stuff, and then you'll kind of see where it applies in like real world designs, right? So next, we're just going to be making this simple gear here, and then you'll see as I go about designing this, I'll be utilizing the constraints. So again, it'll be good to get familiar with this because you'll be doing it a lot. So what I'm going to do with this is I'm going to, create this circle, and then I'm going to create a singular tooth, right? Again, the cool thing about CAD is that you can use the computer to do a lot of stuff for you. And because something like a gear or maybe a pulley has teeth that are all symmetrical or like the same for all of the whole profile, what you can do is you can model one of them and then you can copy it like multiple times throughout your design, right? And while this saves you time because you don't have to model like 50 teeth on a gear, it also will save you time in the future if you ever have to change something. Like for example, if we make one tooth, the tooth too big and we wanted to make it smaller, if we have one tooth that everything else is referencing from, if we change that one tooth, everything else will go with it. So this is kind of where CAD becomes a really powerful program, just because you can do one thing and then it'll modify a bunch of other things at the same time. So let's just get into it. I created a new design, so the new tab kind of thing. I'm gonna make a sketch. I'm gonna click a plane. Personally, I like the top plane for this. And then I'm just gonna start by making a simple circle. So depending on your preference, personally, I like to just draw out a bunch of lines and then like constrain them and dimension them afterwards. Some people like to constrain as they go. It's just kind of a personal preference thing. So if you want, you can do it the way I like to do it. But if you want to constrain each piece as you go, that's totally welcome as well. So I'm just going to start. I'm going to make something pretty rough, and then I'm going to refine it with the constraints. So, all right. So I have this circle here. What I'm going to do is I'm going to draw a construction line. So I don't know if I talked about it last week, but there is something called a construction line. And it's useful when you're creating sketches because you can use it as like a framework for your design. But then when you go to extrude it, Fusion will ignore the construction lines. So you can have a complex sketch with a bunch of construction lines, but then in the end, it'll just be like one simple profile instead of you having to select multiple different bodies. That may sound a little bit complicated. I'll see if I can find a good example in a little bit. But yeah, I'm going to start with a construction line. Basically, what I'm going to do is I'm going to model half a tooth. and then I'm going to copy that half and mirror it across this construction line that I'm making. So to enable construction line, if I click line here, there's this construction button here. I think you can also press C and it makes things construction as well. Construction lines aren't limited to just lines. You can make construction circles as well. So pretty nice. So I'm going to make this construction line. You can see it's like kind of dashed. So that's just kind of to signify that it's a construction line. And then for the rest of the lines, I'm making them normal. So I'm going to disable construction, and then I'm going to go across and down. And maybe not that, that's parallel. So I'm purposely kind of making this a little bit wacky. And then I'm going to apply the constraints to fix it right now. So in this case, you know, the top of this tooth should be parallel or perpendicular with this construction line. So I'll add that here. And then for some reason, these two lines aren't connecting. So I'm going to add coincident to these two endpoints to merge them. And then now I'm going to start adding dimensional constraints. So again, you're not limited to just geometric or dimensional constraints. It's very useful to use both of them kind of together. In this case, I'm just going to make this 120. Let's say I want this distance to be like 100 or something. And then also specify this angle. And then lastly should be this distance. Okay, is everyone good up to this point? Yeah? All right. Sorry? To add the dimensional constraints, it's in the sketch dimension tool. So it's up here in the kind of left-ish area. If it disappeared for you, you can go under create and then it's under sketch dimension at the bottom. Or you can press D, which is the shortcut. Okay, so I have this sketch. It's fully defined. You see all these lines are nice and black, you know, nothing blue, which is good. Obviously, this area is blue because it's closed, which is good. But now that we have this half profile, I'm going to create the full gear tooth. So you'll see right now, this area is highlighted white, and it's because this construction line, again, isn't being like counted towards any extrusion or revolve, right? So there's no closed area here, but when we mirror it, you'll see that it does turn blue, or it should. So to mirror it, we're going to use the mirror function, which is right next to sketch dimension. And then it'll ask us to select the objects we want to mirror, and then the mirror line, or where we're mirroring from. So here, I want to mirror this horizontal line on top, and then this kind of diagonal line here. And then I'm going to select my mirror line as this construction line. You can see there's this nice preview, and then when I press OK, this area is now highlighted blue, right? So because of that construction line, it was open before, but now that we have this mirrored profile, it's nice and closed, and that's what we're looking for. Now again, the nice thing about this is if I change one of these parameters, the mirrored tooth will also change with it. So if I wanted this to be like 80 for some reason, both of them will change together, right? So this is kind of what we're looking for. Does this make sense? So to do it again, you're going to do the mirror tool. So right here, next to sketch dimension, you're going to select the objects that you want to be mirrored. In this case, it's this horizontal and diagonal line. And then you're going to select the mirror line, which is this construction line here. All right. Raise your hand if you need help with this. So now that everyone has this, the last step for this part is to pattern the tooth profile to make the gear, right? Obviously, you don't really want a one tooth gear. That'd be kind of strange. So to fix that, we're going to copy this in a circle. So kind of like the mirror function, we're going to create something called a circular pattern. So if you go under create and circular pattern, it'll ask you to select objects. So what you could do is you could click all of them. I'm just going to highlight them all like this, and it should select all of them. If you didn't know, highlighting certain ways can select things in a different manner. So if you highlight and the box is yellow, then it'll select anything that the box touches. So like because I'm highlighting these lines, they will all be selected. You can see this vertical line is selected. But if I highlight in the other direction and it's kind of like this orange color, it'll only select things that are fully inside the box, right? So because like these diagonal lines aren't fully inside this rectangle I've made, the only thing it'll actually select should be these two horizontal lines. So when I release, you can see it only selects those two. But yeah, anyways, that's just kind of like a little thing. I'm going to go back to circular pattern, so create circular pattern over here. I'm going to select the objects. In my case, I'm just going to go this way, selecting all of these. I'm going to select a center point. In this case, I want all these teeth to be centered along, the center of the circle. So I'm going to click right here. And then it'll allow me to specify, how many teeth and the distribution. Normally, like in this case, I want the spacing to all be symmetric around, the whole 360 degrees. So I'm going to do full. But if you wanted something to be, partial, you can do that too. In this case, it's like it defaults like 180. But if you only wanted it to be like a small portion, like 60 degrees, you could do that. But in this case, I think full is the most relevant in this case. So I can specify a quantity. You can see if I change this number, it'll automatically make more teeth. Oh, 89's quite a bit, maybe not that many. Okay, so I'm just going to do 9. You can do whatever number you want. I just recommend that you make sure that the number of teeth or that the teeth aren't overlapping with each other. So you can see there's a small gap in between. But if you start going higher to like, I don't know, 13, you'll start to get like these areas where both of the teeth kind of overlap with each other. Try to avoid that just because it'll make your extrusion a little bit weird. So, for me, I think my limit is 10 here, so I'll just do that. But once I press OK, you can see there's more teeth. They're all highlighted blue. And if I was to change any of the numbers from the original tooth, they should all follow. So if I make this 80, all of them change together. So, oops, maybe not 10. So what I like to think about it is like you're being lazy, but like your laziness is making the CAD more efficient, right? You could obviously like painstakingly CAD each tooth individually, but if you're just lazy and you just make one and copy them all, it'll make your workflow a lot easier. Again, if you wanted to change one or just like change the angle, it's very easy. And then it'll apply to all of the ones that you've copied. Oops. All right. So I think this looks pretty good. I'm gonna finish the sketch. If you wanted to, what you could also do is you could trim away at all these excess lines here. If you were to do that, then it might make your extrusion a little bit simpler. I'm just going to kind of ignore that for now, and I'm just going to select them all individually. Um, but you'll see when I go to extrude it, you might be like accustomed to it like automatically extruding for you. But in this case, because there's so many different closed bodies, Fusion doesn't know like which one to extrude, right? So you have to select it manually. Again, if you trimmed all these little arcs away, then that would not be an issue. But in this case, I'm just going to be lazy, and I'm just going to select these all manually instead. So you select them. I'm going to select some arbitrary distance. And then boom, we have this gear. Again, if you ever want to edit anything, for example, I think this, like the top of this tooth is a little bit too wide. You can go back and edit it by going in your timeline, right clicking the feature you want and then editing it. Make this like 5 or something. Yeah, let's do that. Okay, that looks a little bit more like a gear. Okay. Everyone good up to this point? All right, sweet. Okay, so the last thing for this assignment is to add this threaded hole. What you could do, or especially for holes, not really threaded holes, but like maybe like your first thought that you might have when making a hole is you could be like, oh, I might just make this sketch, draw a circle and then extruded cut like that circle into my design, right? So, I could do that real quick, make a nice quick circle, dimension it to whatever I want. And then cut into it and then call it a day, right? That's technically like a way you can make that hole. But when it comes to like specialized holes and threads and stuff like that, that's something that is considered bad practice. And the reason is because when you go from design to manufacturing, you want to give as much information to the person manufacturing your piece as possible. Especially when you're in industry, a lot of the times, like you might design something, but you're not going to be the one making it. So you want to make sure you can hand off a part drawing or design to someone, and they'll have as much information as they can to make your part the way you want it. And to do that, for holes, we really recommend you use the hole tool. And that is mainly just because it retains more information about the hole that you've created. So if you're familiar with something called CAM software, which is like computer aided manufacturing, I believe, it can take your design and then it can program something like a CNC machine to create your part. But if you just create a hole with like an extruded cut like this, it'll just kind of treat the hole as just like a feature, right? It won't know that it's a hole. It just knows that there's some area that doesn't have material there. So it may not select a drill bit, which you might want to use for this case, and it might select another tool to kind of cut this hole out. So to give the most information possible, you want to avoid doing this if you're making a hole, circular holes, right? Obviously, if you have like some geometry that has to be specific, please do this. But for holes, there's something called the hole tool. So this hole tool is useful because you can specify like what drill bit to use, like how deep to go, and then you can also add extra features like adding threads and stuff like that. So using this, you can use this tool and then send your part to someone, and then they'll be like, hey, there's a hole here. Like in this case, it has threads. You want to use threads here. Instead of just being, there's some arbitrary negative volume in this area that we need to remove. So it's like a really small, subtle difference, but it can make someone's life a lot easier down the road. So in this case, I'm using the hole tool. You just click hole, and then you can kind of select where you want your hole to be. One thing you can do is you can create a sketch and add in points and then reference that sketch to like have placement for these holes. In this case, it's not really a big deal because I just want this hole to be centered. But if I wanted, for example, a hole to be specifically like in this corner right here, I could create a point in this sketch and then dimension it, fully constrain it, and then I can reference this hole when using the hole tool. So you can see now there's this like floating or this floating point right here. If I click on it, it'll create a hole at that point. Obviously, in this case, I just want it to be centered. So I'm just going to kind of ignore that point and just click on the origin here. But that's just something for you to know if you wanted to make a lot of different holes in different places. Again, you can see here that there's a lot of different different options for you to choose from when selecting your hole type. In this case, I'm just going to kind of leave this as a simple hole here, but you can see that there's different options for different use cases. So I want to just have this go straight through, nice simple hole, but I also want threads. So I'm going to change the hole tap type to thread or to tapped. And then you can kind of see it gives you a preview on the kind of tap that you're applying to here. It's also nice to use the hole tool because you can specify things pretty easily. Again, if I made like a 50mm hole just with a normal sketch and then cut it out, I wouldn't have any of this information, right? So all this information is very useful to machinists when they make your part. So you can specify it here. I don't know, let's make some really large thread just because we can. And make it like 70 by like 4 or something. But yeah, if you're satisfied with it, you can press OK. And then boom, you have a nice hole. If you zoom in, you can see the nice threads too. So please use the hole tool for this assignment. I mentioned last week how like the timeline will be important. This is one of the cases where it is important, right? So if you were to send a screenshot to me with just like the extruded cut, I could look into your timeline and see that this hole tool wasn't there, right? So that would kind of give me an indication on like if you use the tool properly or not. But again, it's useful for me when grading, but it's also useful for you when designing stuff. Do you have a question? Okay, does that make sense to everyone? I know I went on a long ramble about why the hole tool is important, but I hope that makes sense. Just because, you know, when we design things, it's not always just for ourselves, but they're for other people. keeping their thoughts in mind usually will save you headaches in the future. Any questions on this? No? All right, sweet. Okay. So now that we have this, I'll just move on to the next assignment. We're going to make this sweet hair dryer. So now that you're all kind of familiar with all the different constraints, we're going to start adding more geometry when creating your sketches. So typically we've been creating just simple 2D sketches, but now we're going to be creating multiple sketches and then combining them to make a 3D object. So you can see in this slide here, it kind of gives you a preview. We're going to be using something called the loft tool. So basically, we're going to be creating 4 different planes, creating 4 different sketches, and then using the loft tool, it'll create a smooth transition between all the sketches we made to create a nice solid body. So I created a new design here. Typically, what we do is we just jump in and create a sketch, but I'm going to shy away from that and start creating more planes. So typically, when we're used to just these 3 planes when we first start out, right? They're all based off the origin, but we can also create our own planes. In this case, we're just going to be using planes in reference with these planes that already exist, but you can also use the planes referencing things that you've created. For example, like if you had, you know, a cylinder and you wanted to reference like a plane in the middle, you could make a midpoint plane and then select both edges of this or both faces of the cylinder, and then it'll create a plane in the center. I'm getting a little ahead of myself. Anyways, if you go under the construct features here, there's a bunch of different options for you to choose from. I'm mainly just going to use the offset plane and mid plane. I'm just going to be using both of them. You can use all offset planes for this assignment, but I'm just going to use both of them just so you can kind of understand how these tools work. Oh, and my laptop's on deck. All right, so if you were curious, I'm just showing and hiding the origin with this little eyeball up here. But I'm going to add an offset plane to start. So construct offset plane. And then in this case, I want to reference this kind of top plane here because I want this hairdryer to kind of be vertical. And then we're going to grow off or go off from there. So I'm going to select this plane here. And then I'm going to specify some distance that it's offset from. Maybe do like, I don't know, 40. I'm going to show all these planes actually, just so you can see. You can see if I rotate, we have this plane that's kind of sitting above the rest of them, which is what we want. I'm going to make another offset plane, just like that. I'm going to add a good amount more on this one. So we have two extra planes now. If you see, if I rotate, this one's quite a bit higher than the other one. And for the last one, I'm just going to use the midpoint plane just to kind of, or the mid plane, just so you can kind of understand how this works. So in this case, let's say, like I want a plane in between this top one and then this kind of middle one right now. If I click these 2 planes, then it automatically creates a plane in between those two. So we have this stack of planes here. Again, if you wanted to change any of this, you could go into the timeline and edit this. So for example, if I wanted to make this longer, I could do that. And then as a result, the midplane will change with it. Anyone need help with creating these planes? Okay, sweet. So now that we've created our planes, we're just going to create 4 circles on each plane. So we're making 4 separate sketches on 4 separate planes. So now we're going to create sketches. I'm going to start with the bottom one. I'm referencing all of these circles off the origin just to make sure they're all nice and centered. Oops. So drawing off the origin. I'm going to add a nice dimension here. Maybe make it a little bit bigger. I'm going to finish it. And then I'm going to create another sketch on the next plane. Again, I'm doing them all on different planes. For the second one, I'm going to make it quite a bit larger. So here we go. And then again, I make another one. And then I'm going to do one more. Also, for some reason, my snap isn't really working the way I want it to. So that's why I've been hiding and showing the planes, if you were wondering. Okay. So now I have this nice stack of circles. Raise your hand if you need more time. That's fine. The next thing to do is to create a loft. So we're going to create this solid body from the sketches. So I'm going to go under create and loft. And then it's going to ask you to select profiles. So when you do this, make sure you select the circles in the correct order. So for example, if I selected this top one and then one of the middle ones and then go up and then down, it's going to make your loft be really weird and it's going to kind of like fold itself inside out. So you want to make sure when you select your profiles, you're selecting them in order, right? Because how Fusion's going to handle it is it's going to try to create a nice smooth profile from one sketch to another, and then it will continue to go up, right? At least that's our goal. If you select them out of order, it'll like make a smooth profile to the middle one, and then it'll go inside out and go down. So you don't want that. So I'm going to start from the bottom and then go up, but you could also go top down. It doesn't really matter as long as they're in order. So I'm going to select this circle and then this one, and then I'm going to just select my way up. It's under create loft. So if you go under create, you'll find the loft tool here. So I'm going to press OK, and then you can see we have this nice smooth vase-like object. Again, I'm going to do it wrong on purpose just so you can kind of see what might happen. So you can see here, like if I selected it wrong, it'll like turn it inside out, right? So it went to this middle one and then went back down. And it'll give us this weird shape. Although it looks cool, that's not really what we're going for today, so don't do that. We're looking for this. Also, this is a good way to visualize it. If you unhide your sketches, you can kind of see what the loft does, right? It makes this nice smooth curve from each circle that we've created. And it's also pretty cool because if you look at the preview, you can loft different shapes to each other, right? This is not exclusive to just circles. You could do like a rectangle to a circle and it'll make a nice smooth transition. Anyways, now that we have this vase-like shape, we're gonna hollow it out. So I'm purposely gonna do things in a certain order just because I want to demonstrate how you can move features in the timeline. So basically, I'm gonna be creating, or I'm gonna be using the shell tool to hollow out this body. But we're going to move it later, and you'll kind of be able to see what it does. So I'm doing things out of order on purpose, if that makes sense. Okay, so the next step is to hollow out this area here. So we want to take the solid body that we've created and make it nice and hollow on the inside. And to do that, we're going to use the shell tool. So basically what it does is it'll allow you to select a face, and then it'll hollow everything out inside the body that you select while leaving a constant width on the outside. So if you click the shell tool here, I'm just going to click this top face here, and then it'll ask for a thickness, and that's basically how thick you want the wall to be. In this case, you know, I might specify some amount. That's quite a bit, maybe like 5. 5 looks good in my case. Again, the dimensions don't have to be the same. But when I click OK, you can see that the whole thing is nice and hollow, and the shell on the outside is a constant width, which is kind of what we're going for here. Does that make sense? Okay, sweet. After that, we're going to add a fillet. For this, I'm going to be very specific. Make sure when you create this fillet, you only select this outer edge. If you select this inner edge, it'll mess things up in a little bit. I'll purposely select the inner edge just to show you why things could break. But for this, please just select the outer one. I'll just do both so you can see what happens if you do it wrong. Okay, I'll just do like 1.5. Okay, so I've added the fillet on both sides. Again, yours should just be on the outside. The inside should look a little bit sharp, but that's okay. I'm going to leave that there. Next step is to create a nice handle for this. So what I'm going to do is I'm going to create another plane. I'm going to make it offset to one of these planes here. I'm going to pull it out. Personally, for this assignment, I like pulling it out beyond the hair dryer. So, I think 45 in this case is fine. You can see here, my plane extends beyond the body of the hair dryer, so I want that. And you'll kind of be able to understand in a little bit. Everyone good here? Okay, sweet. Okay. Next, I'm going to select the plane that we just created and enter a sketch. So create sketch, going into this plane. And then I'm going to create a circle for the handle. One of the things I like to do is I like kind of drawing it away from where I want it to be. And then I like adding the geometric constraints just to double check. So in this case, the circle should be vertical. And then I can start specifying stuff, right? Distance, maybe make this 40. Looks pretty good. And maybe make this like 40 as well. Yeah, why not? Maybe make this a bit higher. So this circle is going to become the handle. It's nice and centered on this body. Again, I recommend you draw your initial circles all on the origin, and it's for this reason, right? You can use the origin as a reference to all of them because they're all kind of centered on it. It makes your life easier. So I'm going to finish the sketch. You can see here the circle extends a little bit beyond this body, but then I'm going to start an extrude, right? So this extrude is going to be a little bit more complex than the ones that we've been doing before. The first direction is just going to be the standard one that we've done, but instead of one side, I'm going to change it to two sides. So for side one, I just want it to extend this way. So I don't know, maybe not 800, maybe like 150. So I'm going to specify that distance, but you can see that this handle is kind of floating, right? There's no connection between these two. So what I'm going to do for side 2 is I'm going to change the extent type from distance to object. And then it'll allow me to select the body of the hair dryer, and then it'll create an extrude that smoothly goes into the body, right? So if you look at that, it's nice and smooth, and it doesn't like extend into the shell that we've created. This honestly doesn't matter for what we're going to do later, but this is just kind of showing you what this tool does, or what this extent type does. If you were just to go distance and extend inside this body, that's okay because we'll be able to fix it later. But in this case, I just prefer to object. I'm going to set the operation to join because I want this handle and the head of the hair dryer to be one piece. And then I'm going to press OK. So now we have this nice hair dryer. It's nice and smoothly transitioned into the handle. The last thing we're going to do for this handle is create this chamfer here. So similar to the fillet, which rounds corners, I'm going to use a chamfer, which kind of creates, the standard angle is 45 degrees. So it just makes a nice even cut around it. So you just click on the edge and you can see here that it makes this nice kind of beveled edge here. Again, it's not rounded, it's just kind of straight. And that's what we're looking for. Okay, raise your hand if you still need some more time to get to this point. Okay, that's totally fine. Keep going. to the thing that I was talking about, how I purposely did like the fillet wrong and stuff like that. But basically for this, um, let's say, you know, I didn't want this handle to be solid, right? I want it to be hollow so I can fit like electronics, maybe some switches or, cables and stuff inside. So I wanted to hollow this out, but let's say I want to make it all in one operation, right? One of the cool things you can do in Fusion and in a lot of other CAD programs is you can rearrange kind of your timeline, right? So in this case, I could move this loft, I mean, not the loft, I can move the shell to be after I created all these things. And instead of hollowing out just like this kind of vase-like body, it'll hollow out everything, right? But you can only move things in the timeline if it's not dependent on other things, right? So in this case, because I've created this fillet is referencing an edge that was created by this shell, right? So if I go back, I'm going to hide some of the progress that we've made. You can see that there's this edge here, right? And this edge wouldn't exist unless I created this shell, right? So if I made a fillet referencing that, it won't let me move the shell anywhere beyond the fillet because the fillet is dependent on the shell, if that makes sense. So to fix that, if you wanted to move it farther, you have to remove that dependency. So in this case, to remove it, I'm going to have to deselect the edge that I selected for this fillet. So I'm going to edit it. Oops. And then I'm just going to select the outside. So now that this has removed the dependency, I can move the shell. So I'm going to push this all forward. So before I tried dragging this, it wouldn't let me drag it beyond the fillet. But now that I've deleted that, removed that dependency, I can move this shell. You can kind of see. And once I let go, if I click on the shell, you can see that it hollows out not only this head area, but also the handle, right? And it even like hollows it out. It keeps a constant width of everything, including, the chamfer we've made. And, that's kind of what we're looking for. If we like changed some of these, like if we change the order at which we did some of these operations, you might get a different geometry. So like in this case, if you add the chamfer after the shell, you can see like this feature here or this area is kind of thin. But if we changed it so the shell is after, you see it's nice and smooth, or it's nice and constant width, right? So this is just kind of a good example of showing you how doing certain operations in different orders can result in small differences in your part, right? I didn't change, like I didn't add or subtract any features. I just reordered them, right? So depending on what you're going for, you want to keep the order at which you make these things in mind. Does that make sense? Okay, sweet. So for the last thing here, we're just going to create this little wire for the hair dryer. We're going to do that, we're going to make a sweep, which is very similar to a loft. But instead of having multiple profiles along a different plane or along different planes, we're creating something that people consider like a path and a profile. So in this case, this path is just a circle just because it's a wire. I mean, the profile is a circle. And the path it follows is just this simple line here. So I'm going to make two sketches. I'm going to start with the profile. So I'm going to create a sketch, and then I want it to be centered on the bottom of this handle. So I'm going to select the handle. Again, you can sketch something like way out of whack, and then you can use a geometric constraint to constrain it. In this case, I want it to be concentric. And then I set this dimension to like 10 or something. That's good. I'm going to finish this. And then I'm going to create one more sketch. So we have this profile, but I want it to have a path to follow. So I'm going to create another sketch, and this time I'm going to select this plane here. So this plane is going down if you did everything correctly. All right, because everything's on the origin, this plane off the origin should be cutting straight through the whole assembly. So I'm going to click this, and now I'm going to start drawing the path. So I'm going to draw this line out here. I usually just like drawing a straight line to begin, just because it's nice and straight. And then after, I just use this fit point spline. This is not going to be like a fully constrained sketch, just because it's just kind of organic. So I like the fit point spline just because you can make a really nice like squiggly line. So I'm going to click one point, and then as I start clicking, it creates kind of like this organic shape. Once I'm satisfied with it, I can press this check mark, and it creates the spline. One thing you do want to keep in mind is that you probably want to make these two lines, or the spline and the line tangent with each other, so there's a nice smooth transition. So the last thing I'm going to do here is going to make these tangent. You see there's a nice smooth curve from the line, which is good. Again, this is blue, but you don't need to worry about it. I'm going to finish the sketch, and you can kind of see what's going on here, right? There's the circle, which the wire is going to be, and then it's going to follow this to create a nice solid looking wire. So create a sweep. Again, there's a kind of a preview on what it's going to be. And then we need to select the profile and the path. So the profile in this case is this small circle that we sketched, and then the path should be along this line we created. When you do that, creates this nice wire. Good. Any questions? Before leaving, I'm just going to talk about the homework real quick because, in my opinion, this is basically the hardest assignment of this class. And it's just because constraints can be a little bit tricky, especially when you have a bunch of them. Um, so yeah, your homework is basically to recreate an extrusion profile. So extrusion profiles are pretty popular when you're designing things, especially for prototyping, just because these kind of slots here can be used to mount a lot of hardware. So if you ever design and make stuff that is supposed to be modular, a lot of people like to use these profiles. So you can kind of see the sketch looks a little complex, but your homework assignment is to recreate this. Please do not reference this sketch here because there are some dimensions missing. So when you're doing this homework assignment, please reference this photo here. This photo is also kind of here as a hint to how I approached this problem. So you can see here, this was made in another program, so you don't like cheat off me. But basically, you can see there are these dashed lines, just like in Fusion. These are all construction lines, right? So you can see I'm basically making a portion of the profile, and then I'm gonna mirror it, and then circular pattern it, right? It's very similar to the gear assignment that we just did, but with a more complex sketch. So for this, this kind of construction geometry here, this is basically a square, right? So I set these two lines to be equal to each other to kind of give myself a framework to build around. And then I started creating these lines. What you could do is you could make a very simplified geometry of this. So you could like omit all these round pieces and then get this fully constrained. And then you can start adding more complexity, right? You can sketch it without these arcs and then you can add them later. And then, making sure you're adding the geometric constraints along the way should allow you to, fully define this profile. So basically the goal for you is to only use all the dimensions in this photo once, right? You shouldn't have to, like, for example, have 2.9 here and then 2.9 going across, right? You should be able to use that geometric constraint, like the equal constraint, to make them equal to each other, right? So if you can use a clever combination of all the constraints that we learned today, you shouldn't have to be able to add anything to these dimensions, right? So you shouldn't have to like add the length from there to there or something like that. If you have any questions about which one is like dimensioning to which, you can ask me. But yeah, don't worry too much if this is difficult for you because I will say this is, in my opinion, the hardest. But give it your best shot. This is a pretty good exercise in my opinion. It is, a little bit more challenging than what we did today, but it's good practice. So yeah, again, we're all here for you. Me and Hector, like, feel free to ask us in the chat. We'll definitely help. or you can feel free to DM us. We'll try to get back to you as soon as we can. But yeah, that's your homework assignment for the week. If you have any questions, feel free to reach out. But I hope that gives you a little bit of insight into how to approach this. Again, construction geometry can be very helpful in scenarios like this. So that's my little hint to you. But yeah, other than that, we're good to go. I'll stick around for a little bit, help a couple people out. But I'll see you all next week.